Okay, we're talking about functions. This is actually, notice we've jumped around chapters. I keep mentioning that. This is actually 2.1. But you've heard of a function before. You just may not have really known what it is. It's a relationship between the input and output where there's exactly one output for each input. Now I'm going to say something sexist. Function land. Think about X chromosomes, Y chromosomes in your science. XX girl, XY boy. Actually, everybody's born, everybody starts out female until it's determined whether they're going to be male or female. So I'm going to say something sexist in that the X's we're going to think of like the girls. And one really cool thing is that the guys depend on the girls. So the girls are the independent variable. And the guys are determined, or the Y's are determined by what the X's are. Only thing is, though, every X can only have one Y, meaning girls can only have one boyfriend. But in function land, boys can actually have more than one girlfriend, and it can be a function. All right. It's just a way to help you remember which one's which. Now, there is a good function land called the one-to-one function land. In one-to-one, you only can have one girlfriend for every guy and one boyfriend for every girl. So there is one-to-one functions, and there are functions that are not one-to-one. But it's always the girls. The X values must all be different in your set. So Y's can be repeated, but X's can't, and it can be a function. If you're looking at a graph, there's some tests, and now you may not like that little thing I said, but it does help you remember. A function must pass the vertical line test, okay, meaning you can only hit it in one place with a vertical line anywhere on the graph, and it will be a function. But now we're back to one-to-one function land. One-to-one functions must only have one range for every domain output. Now, the domain, guys, are the inputs. All right, so the input, those are your X's, and that's the domain. The output is the range, and those are the Y's, okay, the Y values. You need to know the difference. So input, X's, output, Y values. If you're looking again at the graph, it has to pass the vertical line test to be a function, and if it's one-to-one, it must also pass a horizontal line test. Okay, meaning it can only hit it once horizontally. Equations that represent functions are often written in function notation. For example, y equals 10 minus 8x can be written as, that is read, the f of x, which means the function of x is to take its input, start with 10, subtract 8 times the input. This notation emphasizes the fact that the values of y, which are dependent, y's are dependent, depend on the values of x, or the girls, which are, x is the independent variable. All right, next, we've got to review ordered pairs. This is a relation because it's just a set of points. If we were to plot them, 2, 1, 3, negative 2, negative 3, 1 would be left 3 up 1, and 2, negative 2. Bless you. There's multiple ways to tell whether this relation is a function or not. The x values are 2, 3, negative 3, and 2. Typically, we'd only write them down once. So you've got 2, you've got 3, and you've got negative 3. In the y values, remember all points are x comma y, you've got 1, negative 2, 1, negative 2. So you only got 1 and negative 2. To show how they're paired, the first point, 2 to 1, 2 pairs with 1. The second point is 3, negative 2, so the 3 pairs with a negative 2. The third point is negative 3, 1, and that negative 3 pairs with the 1, which just showed me that two girls have the same boyfriend. There are two x values with the same y value. That means this is not a function. All right, and I had the last one. Oh, we got them all. Oh, also the last point, though, was 2, negative 2. Oh, boy. There's another girl with 2 boyfriends. Or actually, yeah, girl with 2 boyfriends. This one was a, oh, well. Is it 1 to 1? Well, how many points there are right here? there are 4 points. So the domain consists of all the x values of those points, and you typically put them small to large. That'd be -3, 2, and 3. Since there's only 3 domain values, this can't be a one-to-one function. It can't be a function either. But it can't be one-to-one because what's the range? Well, the range has repeated y's, and that makes it not one-to-one. So that'd be -2 and 1. So is it one-to-one? Nope. If it's not a function, it can't be one-to-one in the first place. Another way to tell that this is not a function is over here where the points are plotted. You got a vertical line that would hit 2 points. You also can tell it's not one-to-one because a horizontal line would hit 2 points. So that's multiple ways to view the information. State the domain and the range of each relation. These are relations. Relation is a set of points that's not continuous. This data is actually called discrete, and we'll talk about that again. We're going to determine whether each relation is a function. If it is, we're going to determine whether it's one-to-one. Okay, so the domain, let's just use a D and then a colon. You want to use a bracket and then put in the values that are in the domain. The smallest is 0.4, then 0.5. I don't like to write 0.4, that's just me. Let's see, 0.4, 0.4, we got, repeated 0.4, and we got a 3.1. Right, that's it. Which means this isn't going to be a function because there was a repeated x value. So it's not a function. The range, we'll use an R and then a bracket and put in the values for the range. The smallest of which is 0, then we got 1, 2, and 3. It's asking us if it's a function, and if it's a function, determine whether it's one-to-one. Well, it's not a function in the first place, so it can't be 1, 2, 1. I think I wrote everything down that I'm supposed to about that. Yeah. I don't have to write not one-to-one because it's not a function in the first place. Number 3, domain. X values, the smallest is -7. The next one, -5, 3, and 4. There are 4 points, and none of the x values are repeated, so it is a function. I'll jot down the range first, and then we'll write those answers. The smallest number in the range is the -11, then -2, and 2, and 2 is repeated, so you don't need to write it twice. But that tells me something. All right, because there's no x value repeated, it is a function. Yes, it's a function, but there is a repeated range value, so it's not 1, 2, 1. Am I going too fast for anybody, or are we okay? All right, can't go much slower. So we got domain. Again, just your x values. 0.1 is the smallest, 0.5. and 6, and that's 3 of them. So it is a function. And the range, and it really doesn't matter what order you answer all these questions, but the range is the -3, 8, and 12. That's all 3 different points, so it's 1, 2, 1 as well. Okay. All right, so those were relations because they were just sets of points that would be plotted, just be a bunch of dots. Now we have to look at graphs that are continuous. This one is continuous because it's all connected. It's a lot of points that are connected in a smooth, whatever, shape. It is kind of a shape. What is the domain and range? This is what a lot of kids find hard to grasp or understand where I'm looking at to determine it. So domain, that has to do with your x values, which would be how far does it cover the x-axis. So if I went like this and I went to the leftmost point, what is the value of x for that point? Negative 4 or negative 3? Negative 4. It's hard for me to see on here because it's really, really tiny. All right, so the domain, and see how these are solid dots at the ends, there's nothing open or anything. That would be inclusive of those spots. So we're going to do interval notation now for the domain. It goes from negative 4. And now we want to find the point that is most to the right-hand side, which would be 4. So I'm just showing you how I'm looking down at the x-axis to see what number it's reaching. So another way to do that is say that this is at negative 4. What's that? 1, 2, 3, 4. Negative 4, 4. And this point over here on the right was at 4, 5. Okay, so the domain is from negative 4 to 4, inclusive of the ends. So hard brackets. Right, now I'm going to go vertically, but I can't necessarily use the same 2 points because now I'm trying to determine the range. And you always want to go small to large. So I'm going to look at the lowest point, okay, which would be here, and that's located at, what's that, 1, negative 5? Okay, that's the point 1, negative 5. So the lowest y value is negative 5, excuse me. And then what's the highest y value? Well, that would be right here, where that point ended, which was at positive 5. So that would be your range, from negative 5 to 5. So left to right for domain. Oopsie, I dropped a bunch of paper, so it's just a little noise. And up to down, or down to up, I should say, is your range. Is this a function? Well, ignoring all my blue and my pink lines, or whatever you want to call it, is it a function? Does it pass the vertical line test? You could draw a vertical line anywhere on it. So yes, it would, and it would only hit in one place. But is it one-to-one? If you go horizontally, will you hit it more than once somewhere? And yes, you would. So it's not one-to-one. Okay, we got a little X over here on the next one. Again, to determine the domain, you want to look at the point that goes furthest to the left and see that it goes from here to here, which is negative 4 again. It includes, oh, I don't like you, the highlighter doesn't like me to write with it. It includes the negative, is that 5? I think negative 5. And then all the way, the furthest one to the right. Where's that? That's 4. Okay, yep, that point I got to look at. Okay, so negative 5, 4, and my computer is being slow, so my pen is sticking on me. All right, so that went from negative 5 to 4 horizontally, including them. And then vertically, I'm just highlighting because some people don't see this real well. That's the highest spot. The lowest spot is there. So that would be from negative 4 up to 5. Yes. Here you go. Okay, 3 is not far enough. There's one that goes further to the right. Okay, got to go left to right as far as you can. You good? Yeah. All right, and then for the range, it was negative 4 all the way up to 5. Good? All right, is this a function? No. It doesn't pass a vertical test or a horizontal test. Neither one. All right, this is a relation for number 7, and it's a relation because it's a set of points. The domain is going to be a set of numbers, so you make a bracket. It's not continuous, so you don't use interval notation. The domain is including, and I'm just going to go find all the x values. So I'm looking down from each point up to the x-axis. So I got negative 4, negative 2, negative 1, 2, 3, and 5. Is anybody confused how I'm figuring those out? Nope. Okay. And then the range, I'm just going to look from bottom up. The lowest one's at, is that negative 4? 1, 2, 3, 4. Yep, negative 4, negative 1, 2, and 4. This does it pass a vertical line test? Yeah, it looks like it. Does it pass a horizontal line test? No, it would hit 2 points in 2 different places, so that'd be no. This is by the way, there's another way to call this data. This is discrete. Both of these are discrete because they just produce specific points. The previous problems were continuous because they connected points. Okay, so the second one, domain for this one, let's see, we got -3, -2, 1, 4, and 5. And the range, the lowest one's at -4, -3, -1. And then 3. Is this a function? Vertical line test? Oh, doesn't pass it. And so it can't be 1-to-1 either. Okay, Bree's flipping the page. This is some notation. This is read f of x is, and then that's the equal sign. The f of x is x squared plus 2x, and it says find each value. Well, that means that you're letting x equal 3. F of 3 means what's the function give you when you put in a 3? So the f of 3, that notation simply means to substitute 3 into the function. The function squares its input. This is your independent value of 3, x value. What you're going to get out is a y value. It's like finding a pointer on the graph. If you put in 3, you're going to get 3 squared plus 2 times 3. If I can finish writing. That's 9 plus 6, so the answer would be 15. The f of 3 is 15. The f of -4 means plug in -4. So -4 quantity squared plus 2 times -4 is what we're calculating. -4 squared is 16. Do it in your head. Plus 2 times -4 would be -8. 16 plus -8 is 8. So the f of -4 is 8. Then you say, what's the next one? The f of 5a. Well, sometimes we're going to be plugging in expressions, not just numbers. So if we're going to do the f of 5a, we're going to put 5a in for x. The f of x function squares its input. So you take 5a, the whole thing, and square it. Plus, you do 2 times the 5a. 5a squared would be, don't forget, you're squaring all of it. It's 5a times 5a. So that would be 25a squared. Plus 2 times 5a, 10a. That's your answer. 25a squared plus 10a. The f of 2/3, we're going to take and square 2/3 and add on 2 times 2/3. When you square a fraction, you square the numerator and the denominator. 2/3 times 2/3 would be 4/9. 2 times 2/3 would be 4/3. To combine these fractions, you must have a common denominator. So this is all review. Multiply top and bottom by 3 on the second fraction. 4 plus 12, we got 4/9 plus 12/9, so that's going to be 16/9. All right, we'll move on. A lot of little tidbits here. You've probably done this before. All right, now g of x. G of x, there's usually functions are named f of x, g of x, h of x, j of x, k of x, l of x. You can have all kinds of letters to represent a function. You usually don't use the first letters. You start with f and then go after that, and not any i's or whatever. But anyway, this is just another function. It's the g function, and the g function cubes its input and subtracts its input. So we're going to do 3 to the third minus 3. 3 to the third is 3 times, oops, I don't know why I put a 3 in. What was I supposed to be putting in? It wasn't, the input is not a 3, it's a 5. I could have done the g of 3, but it said to do the g of 5, not the g of 3. Okay, 5 to the third is 5 times 5 times 5. You might want to memorize that because eventually I'm going to expect you to know it. It's 125. And then subtract 5, you get 120. The g of negative 2 means to take negative 2 and cube it, then subtract negative 2. Negative 2 cubed, and I will want you to learn 2 to the third by heart. 2 times 2 times 2 is 8. If it's negative, it's going to be negative 8. Subtract a negative, you add the opposite. So negative 8 plus 2, g of negative 2 would be negative 6. And 7c, we're going to cube the 7c and subtract 7c. So on your calc, I'll show you how to cube a number if you don't know. My computer is not happy. So if you have not don't remember how, if you want to know what 7 cubed is, you hit 7, arrow up. Cubed, the new operating systems on the current calculators will look like that. If you have an old one that's like an 83 or something, it's going to have a arrow and then 3. That's 343. Just going to close this up because I really don't need it. Okay, so this would be 343c to the third minus 7c, and you can't combine those terms. Questions? All right, so just another example of what's discrete and what's continuous data. A number of pages in a book is discrete because you can count how many there are, okay? A shoe size is discrete because they only come in wholes or half sizes, okay? You can't do 5 in a size 5.2. They don't have it on the shelf, okay? Number of people is discrete, that you're counting and how many people there are. It's going to be a definitive answer. Something that's continuous, example, the length of a film, because you can have 1.2 millimeters if you wanted. You can have decimals. So temperature is also continuous, and a time it takes to run a race would be continuous. You don't have to write any of that down, guys. We're just looking together, and we're going to pick one in a minute. Okay, so here we'll do our own example. All right, so let's do consists of individual points that are not connected. So an example, whatever, if you were counting, 1, 1.5, 2, 2.5, it's okay if they have decimals, but not things in between those decimals. So it's just counting. So applications, that we said shoe size was an example. Okay. Discrete, continuous data is when the domain has an infinite number of points. It can be graphed as a line or a smooth curve. These are points that are not connected when it's discrete. So application, we said temperature was an example. When you can go from, well, even a range of data, so like 1 to 10, there's all kinds of numbers between there, right? There's lots and lots of infinite decimals in between there. You could keep on writing numbers that are between 1 to 10. All right, smooth continuous curve. All right, what kind of graph is this? What would a y equals 3 represent? We should know it's a horizontal line, okay? That should be something you graph immediately. We reviewed it briefly one day. Now, if that's it says to graph the relation or equation and determine the domain and the range. Determine whether the relation is a function, is it one-to-one, and state whether it's discrete or continuous. This would be continuous. It's a function, yes, it passes the vertical line test. Its domain would be from negative infinity to infinity. All real numbers. What's the range, though? There's only one value for y. Y is always 3. So you have to use brackets, not interval notation. If it's not, it is a function, but is it 1-to-1? It doesn't pass a horizontal line test because it is a horizontal line. So that would be no. Now, the next diagram, x squared minus 1. That's what that little chart was for. It wasn't for the previous question. These are just a suggestion of values to plug into the function. Well, it happens to be a function, but I didn't need to tell you that yet, but we need to substitute in some values. So your inputs are -1, 0, and 1. That's just a suggestion. We can try more if we want. What you're supposed to do to get your y values is take your input values and square them, and then subtract 1. Well, you might want to do this in your head, otherwise you better put the parentheses around it or you could get it wrong. Because if you don't put the parentheses around it, you're going to get -2, and that's not correct. -1's quantity squared would be -1 times -1, which is 1, and 1 minus 1 is 0. If we put 0 in, we're going to get -1. I hope we can do that quick in our head. And if we put in 1, we're going to get 1 minus 1, 0. So I'll go ahead and plot those. -1, 0, 0, -1, and 1, 0. And then I'm going to suggest that we put in -2 and 2. Because I feel like I want you to see more of a graph and realize that whatever's put in this t-chart does not have to be your limit. If I put -2 in, -2 quantity squared minus 1 would give me 4 minus 1, which is 3. And if I put in +2, I'm also going to get 3. So these are 2 more points on the graph. This graph is a U, if you will. It's kind of hard to make it. Try not to make it look like a V. Does anybody know the name of that? Yeah, parabola. I'm sure you did these in Algebra 1. And we're going to do a whole quadratic unit. This passes the vertical line test, so it is a function. You are boundless in what you can put in for x, so the domain would be -infinity due to infinity. Now, you may say, well, that graph doesn't look like it's getting that wide. Well, it does. It keeps going forever, and it really literally gets wider and wider. There's anything, you can square any number you want in the real numbers and get a value for y. The range is restricted, though. So what's the lowest most point? Well, that's right there, right? And that was at 0, -1. So that would be -1 included. And then it goes up, 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 and the arrows say going up, 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 and beyond. So we got -1 to infinity. It would not pass a horizontal line test, so it's not 1-to-1. You could rack it in more than one place if you did that line right there. What kind of graph should this be? Just a line. Okay, it's in that y equals m times x plus b form. All right, b is the y-intercept. That's 2. The slope is 3, so you go up 1, 2, 3, right 1. Do that a few times, or go in reverse. Down 3, left 1. And you make a line. Try to hit your points. Ooh, I did pretty good. This is, yes, it's a function. What can you multiply by 3 and add 2? Any number you want. Okay, so domain, it's going to get wider and wider, so it's -infinity to infinity. And the range, the arrows are pointing up and down. They're going forever in both directions, so that'd be -infinity to infinity too. And it is 1-to-1. Okay, so let's go try a few more together on 14a. Okay, let's try to determine whether the graph's linear or not. Do you think the first one on 14a is linear? Nothing's squared, nothing's cubed, no powers other than x. This is going to be a line. Okay, so this is going to be a line. And then if it's an x squared, it's going to be a u, not a v. If it's x squared and it's got a negative number in front of it, what do you think that might do? Remember anything from Algebra 1? That number being negative this one's going to go up, this one's going to go down. All right, so I'm just giving you a hint. They're going to be some of these are going to be really skinny. All right, so let's get started. The line's simple. We got a b value of 0, so we'll start at 0, 0, and go up 5, right 1. Do it again. And then down 5, left 1 twice. And you got that line. Lines are functions. Their domains are boundless, negative infinity to infinity, and so is the range, as long as they're not vertical or horizontal. The second one, they're suggesting we do a t-chart. Okay, probably can't fit many more. I can't fit too big of numbers in there because I got to multiply the results by 5. So let's just use these values. If I put in -1, 5 times -1 quantity squared, you have to square the -1 first. That would be 5 times 1, so you get 5. If you put in 0, you get 0. And if you put in 1, you get 5. So this is just a very skinny parabola. It's supposed to be a U, but it's hard to make it look like a U because it's so squished. It is a function, and its domain is negative infinity to infinity. The range is restricted. Its lowest point is at 0, 0. So we start there, 0 to infinity. All right, the next one, we suggested that it should open down. Let's see what happens when we plug in a number. -5 times -1 quantity squared plus 2. -1 squared is 1 plus 2. So we've got -5 plus 2, which is -3. If we put in 0, this whole term's gone, and you'd get 2. And if we put in 1, we're going to get -5 plus 2, which is -3 again. Notice that parabolas have symmetry, meaning they have 2 points that kind of match on either side. So -1, -3, plot that, 0, 2, and then 1, -3, and that made it go down. It's still a function, and its domain is still negative infinity to infinity. However, the range is a little bit harder to write. Remember that we are supposed to go from left to right or down to up. So what would be down? Yeah, pointing towards negative infinity, and then it's capping out at 2. And it's including 2. You get soft bracket, negative infinity, comma 2, the hard bracket. Okay, do a few more together. This one's a line. Starts at 1 on the y-axis, and it has a slope of -3, which is down 1, 2, 3, right 1. Or up 3, left 1. And all your lines, by the way, remember the word oblique from algebra or geometry. Oblique And if you haven't finished geometry, no, you don't. But oblique, remember oblique was leaning. Okay, slanted line, oblique line. That's all it means. At an angle. It's not vertical or horizontal. All right. This next one should be a U. Okay, and if you put in -1, you're going to have 4 times -1 quantity squared minus 3. And I'm going to tell you, at this next quiz this week, I didn't decide if it's going to be Thursday or Friday, probably not till Friday. If you square a negative, you get a positive. You need to remember that. Don't rely on the way you're just typing it in a calculator, because this is 4 times 1 minus 3. That's 4 minus 3, and that's 1. 0 entered would give you -3, and putting in +1 would give you 1. It's another U because it's squared. They are all functions, the ones that are the U's, parabolas. And the range you have to watch out for. So this one got to the lowest point of -3, which is included in the range up to infinity. Okay, and number 6 is also linear. It's a line. Start at 4, up 1, right 2, up 1, right 2. And I'm very quick with the lines now because everybody came knowing how to graph lines. Hardly anybody missed a line question on the quiz. Okay. Yes, it's a function, and then you know the domain and range on the lines that are oblique are both -infinity to infinity. Okay, just got a couple more that we'll try to finish up here. This one, careful of the negative sign out front. Very careful. It's saying the opposite of x squared plus 3. When you square 1, you get 1. When you square -1, you get 1. This is actually going to be -1 plus 3, which is 2. You apply the negative sign last. So 0 put in here would give you 3. If you put in 1, you're going to get -1 plus 3, and that's 2. This parabola should be opening down. And this is what it looks like. You could put in some more numbers if you like. -4 plus 3 would be -1. And -4 would be, well, I guess +2 and -1 is what I meant to do. You don't have to do this, but I chose to, oopsie, I missed. All right, so your assignment, I'll finish this off real quick. This is a function. Its domain's -infinity to infinity. Its range is -infinity up to 3. The ones that were linear, I think it was 1, 4, 6, was it? Once ones made lines. Was it 1, 4, and 6? Just doing it by memory, yeah. All right, and this one is a cubic. I'll tell you what it looks like. It should do this. So I'm going to quick do this one. If you cube a -2, you get -8. -8 plus 2 is -6. -1 cubed is -1, so you'd get 1. When you plug that in, if you put in 0, you get 2. If you put in +1, 1 plus 2 would be 3. And 2 cubes 8, 8 plus 2 would be 10. Those would be your points. -2, -6 is here. -1, 1 here. Guys, 0, 2, and then there's a twist right in here. I'll just show you the twist quick. It comes from way down low, and then it always twists right in here where a couple points are close together, and then it just zooms up. So it is a function, and its domain and range are both negative infinity to negative infinity. Negative infinity to infinity. I said that wrong. All right, so your assignment, you've got the next page, 14b, which I can help with and we'll check. And then 15, you've got some graphing and an outline for graphs. We're going to have a work day tomorrow, so you will have some time to ask questions and stuff tomorrow.